Numericals in electric current lesson. This complete recording of all the numericals in that lesson. Okay, so then the first question here is a 10-volt battery of negligible internal resistance. So there's no internal resistance. The small r is not there, negligible. A 10-volt battery is connected to a 200-volt battery and a resistor of 38 ohms. So you have a 38 ohms and you have another 200-volt battery across as shown in the figure. Find the value of the current. I have already told you when it's negative and negative is connected, you have to subtract. Haven't I said that? So when it's negative, you know it's 190. The total potential becomes 190 by the total resistance is 38. When you divide this, you are supposed to get the answer. 38 5s are 8 5s are 40, 5 3s are 190. So the answer is 5 amps. Done. So it's very simple. When the negative and negative is connected, you have to subtract the total EMF, correct? And E1 minus E2, and the resistance is total resistance. So then therefore the current itself is the potential difference 190 by R. The same sum you can also approach using loop rule. If you're going to say, suppose take it like this, you start from here. First mark current. It's just one circuit, right? It's just one circuit. You can't mark it I1, I2. You can just have to mark it as I. That's all. Only one I through this entire circuit because it's all series only. So when I say I'm going like this, take the car. Can we start the car from here, from the battery? 10 volts to this plus 10 volts. Come here. Current is coming the same direction, minus 38I. Then come here, minus 200. Close the circuit is equal to 0. Minus 190 minus 38I is equal to 0. So 190 is equal to 38I, I is equal to, there will be a negative sign of course, 38, which gave 5 amps, which shows that, what does the negative sign indicate? It just shows that the direction in which I have assumed the current is not correct. It should be the other way around. I should have assumed the current to be going in this direction instead of this direction. That's the only difference. You don't have to worry, they are not asking you for the direction of the current. The current you can assume in any direction. If you get the answer as negative, it means assumed direction is wrong. You can always change it, but you don't have to change and do it. You just have to leave it like that. That's all. So that's the first question, we got the answer. So let's go to second question. A copper wire of radius 0.1 millimeter and resistance 1 kilo ohm. So the radius of the copper wire is 0.1 millimeter. Millimeter to centimeter, 0.1 into meter is 10 to the power minus 3 meters, millimeter to meter. And the resistance is 1 kilo ohm, which is 1000 ohms. Connected across a 20 volt, you are taking this copper wire and you are connecting it across a 20 volt battery. How many, okay, so then this is a thick wire, a radius is given and resistance is given. How many electrons are transferred per second between supply and the wire at one end? How many electrons? How many electrons? Okay, you can find only the current because you have a radius, you have the total resistance also. The resistance of this wire has been given. The radius has been given. Resistance has been, if you know the resistance and you know the voltage, you can find the current. There is no need of radius at all, correct? You can find the current I is equal to 1000 by, no, 20 by voltage by, does it have any internal resistance? A copper wire of radius and, okay, how many electrons are transferred? No. The internal resistance of the battery and all is not even there, okay. So I is equal to 20 by, so it's 1 by 50. That is the value of the current. Are they asking for the value of the current? Find how many electrons are transferred. You know the current. And I is equal to Q by T per second. Per second means time is 1 second. So I will be equal to Q. Therefore, you know Q will be 1 by 50 is the total charge. Total charge. But number of charge is different. Q is equal to N into E. Quantization of charge. You remember? So N is equal to Q by E, which is 1 by 50 into 1.6 into 10 to the power minus 19 should give me the number of minus 1.6 to the power minus 19 is E. That should give me the number of electrons. Can you do this calculation and tell me if you are getting the answer? So when you divide this, you get this as 8 and 1 by 8 itself is 0.125 into 10 to the power 19. The minus 19 goes up and so you get this as the answer. Look at this is 1.25 in 10 to the power 17. How is it 1.25? If I multiply the shift the position to 1.25, which means I am multiplying by 10. It will become 10 to the power, it will become 10 to the power, I have multiplied by 10. multiplied by 10 so that this moves, which means I am also dividing by 10. It will become 1.25 into 10 to the power 18 only. No, how is it? I have written 10 to the power 17. Okay, this is 50. So it's not 8, it is 80. 80 means one of the power can go up, it will become 10 to the power 18. So 1 by 8 itself is 0.125 in 10 to the power 18. So 10 to the power 17. Okay, so then thus you get a 1.25 into 10 to the power 17 amps. So that's the first part of the answer that you've already got. Next, what are they asking? Write down the current density. What is the current density formula? Current density is current per unit area. Current per unit area, did you get the current? Current is somewhere here, it's 1 by 50. Per unit area is pi r square, the cross section area, correct? And so 1 by 50 into pi into r square, 3.14 into radius itself is 0.1 into 10 to the power minus 3. 0.1 into 10 to the power minus 3 will give you, that's the simple calculation, it must get you a 6.37 into 10 to the power 5 as your answer. Are you clear? That's the current density. Let's go to the next question. The third question. Find the resistivity of the conductor in which the current density is equal to, current density is J, which is I by A, is 2.5 ampere per meter square. When the electric field is 15 volt per meter, electric field is 15 volt per meter. You know that the relationship between current density and electric field. You know that the current density is sigma times electric field, which is conductivity times electric field. So with which this itself is 1 by rho, resistivity. So resistivity rho is equal to, take it that side, E by J. If you know the electric field which is 15, you know the J 2.5, you can divide that and you can get the answer. So 2.5 into 6, so 6 ohm meter. Are you clear? You know this relationship, right? So that's about it. So let's go to the next question, the fourth question. A wire of resistance 10 ohms is stretched thrice its original length. This resistance is 10 ohms. It's going to be stretched 3 times, thrice, correct? It's stretched 3 times the original length. If L is the now new length is 3L. What will be the resistivity, new resistance? Resistivity never get affected because of length and area. Resistivity rho is a material constant. The resistivity unchanged. Resistivity remains unchanged. What happens to resistance? Resistance does change according to length and area. Rho into L by A. This is the initial resistance. The final resistance is R dash. You don't have to look there. Final resistance is R dash, which is resistivity into 3L because you are stretching it. What happens to cross section area when you are stretching it? Have they specified anything like that? Let's see. The wire of 10 ohm resistance, what will be the, is stretched thrice its original length. Definitely it will affect if you are stretching a wire, the radius will also get affected. If the length is getting, but what you know is the volume of the wire remains unchanged. The volume of the initial wire, what is volume of the initial wire, is equal to volume of the final wire. Okay, so then since when you stretch the volume remains unchanged, the volume of the initial wire, let's take it as a cylinder, pi into r square into L is the original volume, will be equal to pi into r dash square, the new radius, into the length is 3L. They both have to be equal because volume remains unchanged. The pi and pi get cancelled. L and L also get cancelled. So r square is equal to 3r dash square. So the new radius, okay, let's r is equal to root 3 into r dash. The new radius r dash is r by root 3. So you can substitute in this rho into L by A. L is 3L. By A it's pi into r square, which is r by root 3 the whole square. When I do that, the root 3 becomes 3. Root 3 the whole square 3, and this 3 goes up and become 9. So it will become 9 rho L by pi r square, which will be 9 times the original resistance. This is pi r square, right? The original resistance r is equal to rho into L by A pi r square. So can you see it's 9 times. So if it is 10 ohms, it will become 90 ohms. So the 10 ohms now becomes 90 ohms. Are you understanding? So fourth sum is over. We got the answer. Let's go to fifth question. The fifth question, a wire has a resistance of 16 ohms. Or wire, it has got resistance of 16 ohms. It is now melted and drawn into a wire of half its length. So you are making it into half the length, because thick ஆகிடும் automatically the same volume when you melt. So making it half the length. Calculate the resistance of the new wire. What is the percentage change in its resistance? Okay, percentage, first we'll find the new resistance. Idoda length is 16 ohms. Volume is, this volume is equal to this volume. We'll treat it as the volume of the cylinder. So for the first one, it's pi into r square into L. For the second one, it's pi into r dash square into L by 2. So we can equate both of this. So pi and pi get cancelled, L and L get cancelled. If you equate this, you get r square is equal to r dash square by 2. Therefore, r is equal to r dash by root 2. Therefore, r dash is root 2 into r. Let's find the new resistance. The original resistance is rho into L by pi r square. But the new resistance is rho into L dash, which is half the length, L by 2. Into pi into r square is root 2 r the whole square. You can imagine that this root 2 will become 2. And there's a big pi here, right? There's a big pi here, so it will go up. No, it will go down, sorry. Correct, the big pi is here, it will go down, 2 root 2, it will become 1 by 2 root 2. Now, this will become not 2 root 2, it's become 2, 2 2s are 4, so it will be 1 by 4 into rho into L by pi r square. This itself is original resistance, and new resistance therefore is 1/4 of the original resistance. Are you clear? Our new resistance is 1/4 of the original. What is the resistance of the new wire? If you know the resistance of the first wire is 16, so it's 16 by 4 is equal to 4 ohms. That will be the resistance of the new wire. Percentage change in the resistance. What is the meaning of percentage change in the resistance? New resistance by original resistance into 100. New resistance is 4, original resistance is 16 into 100. This is by 4 and this itself is 4 2s are 8, 5, 25%. What? Oh, percentage, this is the new resistance. The change will be 75%. Ayyo, we would have written it as 25, but the percentage change will be 75%. Oh my god. Okay, so let's, if I know the answer, I can see and write, otherwise I'll write 25%. Okay, so let's go to next question. The resistance of the wire is r ohms, is r ohm. What will be its new resistance if it's stretched n times? I'm going to stretch this wire n times. Okay, n times. Now, so then the length is becoming NL. Original length is L. You know that the area is going to get affected. That is the volume of this is pi r square L. The volume of this will be pi r dash square NL. Equate both of this. Pi r square L is equal to pi r dash square NL, where L and L get cancelled, pi and pi get cancelled. Therefore, you get the ratio. You get this also pi r dash square, right? Pi r dash square NL, correct? So you get r square is equal to r dash square into n. R is equal to r dash into root n. R dash into root n. This r dash therefore is r by root n. Okay, so then that's a radius relationship. Let's find the new resistance. R dash is rho into L. L is n into L. By A is pi into r by root 2 the whole square. So when you do this, this will become just 2 and it will go up. Correct? 2, and there is also an n. 2 and an n. Rho L by pi r square will be the original resistance. So r dash is equal to 2n times the original resistance. So 2n into r. R dash is equal to 2n into r. So why is that I am not getting an answer? It says n square r is the answer, whereas I have got a different thing as an answer. Let's see what is the mistake. R dash root n. For some reason I wrote it as 2. It has to be root n. So this will be root n. So it will be n. So n into n, not 2, n square. So then that it's n square into r. Okay, so this you can mug up. Any wire when extended 2 times or 3 times or 4 times, it is that square into r. You don't have to do all this calculation. So now let's go back to the previous sum. This was extended how many times, this wire? It was halved. Yeah, so it's half the whole square, half the whole square, which is 1 by 4th, which is what you already got. If you mug up that when a wire is stretched, the volume remains same. It is our new resistance is n square into the original resistance. If it's 1 by 2, if you are reducing it by half, that n refers to how many times you are reducing it to. It's very simple. If you can mug it up, otherwise do it like this, it's your wish. So then let's go to next question. That 7th question is 2 wires A and B of equal masses and of same metal. Of same metal, equal masses are taken. The diameter of wire A is half the diameter of B. So diameter of B is bigger.
Sorry, the length will also.
Diameter. So then the radius will be also half. If this is r, this is 2r. Or if this is r, that is r by 2. This radius is r, this radius will be r by 2. If the resistance of wire A is 24 ohms, calculate the resistance of wire B. That's the question. So it's the same material, same mass. The radius is r. What about length? Two wires A and B of equal mass and same metal are taken. The diameter of wire A is half the diameter. The resistance of the wire, they didn't specify anything about the length. They didn't specify anything about the length. And they are not stretching this wire, they are just taking two different wires.
Okay.
So I just have to assume that both of them have the same length. I don't have a choice. Okay, what is the resistance of the first?
The same length, won't the mass differ because B is thicker?
Oh yeah, good question. Since the mass is the same, okay, so I'll have to, very good question. So since the mass is the same, the radius is more and the mass is the same.
The length will be
mass
smaller
of
for
let's think. Okay, there is this point called the mass is the same. The mass of this and mass of this is the same, and you know density is mass by volume. So mass is equal to density into volume. Okay, so then the mass is equal to density into volume. The density into volume of this, the volume may be different in this, but the masses are the same. The density of any material is just the same. Let's say density is the same. Okay, so then let's assume that density into volume is equal to this density into this volume. Okay, I am really not sure. I am just trying the sum in front of you. I really not sure. Since the masses are the same. One second, hold on. Can we say the density is the same? And so then therefore the volume is also the same. Okay, let's do the sum and see if you are getting the answer. So volume of the first wire is pi, it's a cylinder, r square h, which is r square L, which is r by 2 the whole square into L, is equal to pi r square into L dash. Okay, pi and pi gets cancelled. So r square by 4 into L is equal to r square into L dash. R square get cancelled. So L dash is equal to L by 4, the new length. So let's calculate the resistance of the r dash new wire. Rho into L by A, which is L by 4 into A is pi into r square, which is r by 2 the which is r by, which one am I calculating? R square, pi into r square. Yeah, this is the new length and this is the new radius is only r square, and so r dash is equal to rho. You know original resistance will be rho into length is L by A is pi into r by 2 the whole square, which means r is equal to 4 rho L by pi r square. This is the original resistance, and what happens here is 1 by 4th rho L by pi 4. There is a 4 also missing. The original resistance has got a 4. So then it has to be 16 times, right? Only when it is 16 times the original resistance. R dash is 16 times the original resistance. That's when you get this, correct? And what is the original resistance given to be? 24. So which means 16 into 24. I don't know. 24 into 16. What is the answer that I have given here? It's 1.5 ohms, correct? It's not working out. I am not getting anywhere near it, correct? Yeah, everything that we have done is correct. It's all perfect. Only thing is, you see this R dash is rho into L by 4 pi r square, whereas original resistance is 4 into rho L by pi r square, correct? So can you see the relationship between this and this? If I multiply this with the 16, I will get R. So which means a 16 into R dash is equal to R. If I multiply 16 with an R dash, I will get R. So 16 into R dash is equal to R. R dash is equal to R by 16. That's the mistake. So then therefore R itself is 24. At 24 by 16 will fetch you this answer, 1.5 ohms. Okay, are you clear? So then if the masses are the same, then obviously their volumes are the same, because density of every metal will just be the same. So I hope you are clear. Let's go. I am recording, right? I am recording. So let's go to the next question. The 8th question. A copper wire has a resistance of 10 ohms and a cross section area 1 millimeter square. A 10 volt exists across the wire. Okay, a copper wire has got 10 ohm resistance. Cross section area itself is 1 millimeter square, which is 1 into 10 to the power minus 6 meter square, because 1 millimeter is 10 to the power minus 3 meters, the whole square, because it's area minus 6. Okay, are you clear? 10 volt exists between the wire. The voltage is 10 volt. Calculate the drift velocity of the electron. The number of electrons per cubic meter, small n, is 8 into 10 to the power 28 electrons are given. Okay, calculate the drift velocity Vd. Okay, Vd is, there are many formulas we know. I am just thinking because number of electrons is known, I is equal to Ni Vd. Can we try that? I is because you know V, that this is not V, Ni Vd, NEA Vd is the drift velocity. Can we use this formula? We can't, but we have put V. You can write it as capital E into small e by m into relaxation time, and E can be written as V by L. Would it help? Let us see. So what is the sum? A copper wire of 10 ohms and cross section area 1 millimeter square, 10 volt. You know the voltage, so then therefore no need for all this unnecessary thoughts. You know the voltage and you know the resistance. I is equal to V by R. So 10 by 10, therefore 1 amps is the current. You know the current, you put I is equal to NEA Vd. So Vd is equal to I by NEA. You know the current is 1 amps, N is the number of charge per unit volume which has been given here, small n is 8 into 10 to the power 28 into charge of 1 electron is, charge of 1 electron is 1.6 into 10 to the power minus 19 into area of cross section is 1 into 10 to the power minus 6. You just do the calculation, you get the drift velocity. Are you clear? Very easy. When you know the potential, you know the resistance, immediately you can calculate the current, and then I is equal to NEA Vd will help you to get the drift velocity. Can I go to next sum? The 9th question, the resistance of the platinum wire of platinum resistance thermometer at ice point is 5 ohms. At 0 degrees Celsius, the resistance is 5 ohms because R0. And then and at steam, which means at 100 degrees Celsius, R100 is 5.39 ohm. When the thermometer is inserted in a hot bath, okay, so you are keeping it in ice, you get 1 resistance. You are keeping it in steam, you get 1 resistance. Now you are keeping it in some hot bath, some water. I don't know what is the temperature of that water. Some hot bath I am keeping. The resistance of the platinum, in this case the new resistance is 5.975 ohms. Some hot bath, which is at some particular temperature, T degrees Celsius, I don't know. Okay. So then calculate the temperature of the bath. This T is what I have to find. Okay, so you know that, let's take this for example at 0 degrees Celsius and 100 degrees Celsius. The variation in temperature, I forgot to teach you the coefficient of resistivity. R is equal to R naught into 1 plus alpha T plus beta T square. This is known as the coefficient. Can you see coefficient? An quadratic equation where this is actually T, it's delta T, a change in temperature. When the temperature increases, the resistance increases for a copper. Okay, so R is equal to R naught into 1 plus alpha T plus beta T square. However, we can ignore this because it's delta T the whole square, right? A small change in temperature, the whole square. 1 by 2 a square panna becomes 1 by 4. It becomes more and more negligible. Therefore, you can ignore this and write R is equal to R naught into 1 plus alpha T and ignore the beta T square. Okay. So this is for a copper. That is why if you brought, similarly this is coefficient of resistance alpha. Coefficient resistivity means rho is equal to rho naught into 1 plus alpha T. Same thing you will write with rho. So if you plot a graph between resistivity and temperature in Kelvin, it will be parabolic, right? It will be parabolic. Moreover, you substitute temperature as 0. You still have R naught. So then the graph there will be rho naught. There will be some resistance here. It will be parabolic. Whereas for a nichrome wire, it will be like this. It will be very slightly dependent on temperature. Whereas copper drastically depends on temperature. Resistivity for a nichrome. For manganese, it will be independent of temperature. For manganese, it will be completely independent. For a semiconductor, resistivity versus temperature in Kelvin will be like this. When the temperature increases, the resistivity decreases for a semiconductor. Whereas the temperature increases, resistivity increases for a copper metal. So this is something I missed telling you. This graph is very important. Nichrome, copper. Okay, so then therefore T refers to small change in temperature. When you square it, it becomes negligible. Rho is equal to rho. This alpha is known as temperature coefficient of resistance or resistivity. So let's take this sum. The change in temperature from here to here is 100. Let's write an equation like this. Okay, resistance at 0 degrees Celsius is this. Resistance at 0 degrees Celsius, what is it? R naught? 5 ohms. Resistance at 100 degrees Celsius is 5.39 plus 1 plus alpha into change in temperature is 100 degree between that, with which you can find what is alpha. Can you find what is alpha from this? Yeah, what will be alpha? You can it will go as division, is it? 5.39 by 5 is equal to minus 1 is equal to alpha into 100. So if you want to find alpha, this will become LCM and it will come like this. Yeah. So 5.39 minus 5 will be 0.39 by 500. The 100 will get multiplied with 5. This is equal to alpha. So you are able to find what is the, and you can multiply both sides, numerator and denominator, by 100. 39 by 50. This will be my alpha. With the first two equations, you found what is alpha. Now take the second one. Can you compare this with this? Compare the first with the hot bath T. You know, write the same equation. What is it? R is equal to R naught into 1 plus alpha T dash, which is the temperature difference between the 0 degrees Celsius and the hot bath. Correct? Hot bath, the temperature variation. So you know that a temperature at 0 degrees Celsius is simply 5 only. The temperature at that hot bath is 5.975.
Oh, they gave that.
At hot bath, what is it? Resistance at a hot bath is 5.975. Is 1 plus alpha, you know, 39 by 50 into temperature is the temperature difference between the hot bath and the 0 degrees Celsius. By doing this calculation, you can find what is the temperature of the hot bath T. You will get this answer. Are you clear? Yeah. Can I go to next one? It is the 10th question. The 10th question, a wire of resistance 4R is bent in the form of circle. When you bend a wire of resistance 4R in the form of circle, what will be the effective resistance at the end of the diameter? Means this is the end of the diameter. So you have to extend this. So it will be, the 4R will become 2R there and a 2R there, and these two has to be treated as parallel. You can't treat it as series. You have to treat it as that part and this part as parallel, because the current going will get split up. So it's 2R into 2R by 2R plus 2R, or in other words 1 by 2R plus 1 by 2R, and you will reciprocal it. Either you write 1 by 2R plus 1 by 2R reciprocal, or R1 into R2 by R1 plus R2, which is 2R into 2R by 2R plus 2R, which is 4R square by 4R. 4 and 4 get cancelled, it will remain to be R. So answer is just R. Are you clear? Let's go to next question, 11th question.
That was a direct question.
Yeah, yeah. So 4th question is a 100 volt is applied. Am I recording? Yeah, a 100 volt is applied to the ends of a copper wire, 1 meter long. A 1 meter wire, a 100 volt is applied. If you know the resistance, you can find the current. Correct? I hope we know the resistance. Let's see. Calculate the BD. Yeah, drift velocity is what they are asking. Compare its thermal velocity at 27 degrees Celsius. They have given current density itself. They have given 5.81 10 to the power 7. If you know current density, you can find E is equal to J is equal to sigma into E. Correct? E itself is V by L. You know the potential. Potential is 100 volts. You know the length L. You can substitute here, and current density is given, with which you can find J. And if you know J, it's I by A. So with which you can find the current through the wire. Provided you know the A. Do you know the area of cross section? You don't know the area of cross section, but you can write I as NE. Even you don't know, you can write I as NEA VD by A. A and A also gets cancelled. You don't need an area. So you know N into E into VD. You want to find VD, you know J. With this you can find what is VD. How is the sum? Superb. So let's go. This is more or less all sums are similar, but slight variation which you have to think. Okay, so then let's go to next question. The 12th question, from here onwards it's a straightforward questions. So then you have a wire like this. Can you see that this does 30 ohms here, 30 ohms here, and it's like this. This and this is in series. Correct? So 30 is 60 ohms. This 30 and this 60 is in parallel. So 30 into 60 by 30 plus 60 is 90, which is 1800 by 90. So 920. The equivalent resistance therefore with this becomes 20 ohms. You know the potential itself is 2 volts. Therefore, you can find the current through this. I is equal to V by R, which is 2 by 20, which is 1 by 10 amps, which is 0.1 amps is the current that is flowing through here, correct? Now calculate, what is the question? Find the value of the current in the circuit. We already found 0.1 amps. That's all. How is it? Find the equivalent. Very, very easy sum. So let's go to next question. The next question diagram goes like this. You have an EMF which is 60 volts. You have an 18 ohm resistor, a 10 ohm resistor, and a 5 ohm resistor. What is this resistor? This is a 10 ohm resistor. Have I drawn everything? This is a 60 volts. This is 18 ohms. That is 10 ohms and 10 ohms, and this is 5 ohms. This is circuit, okay? Determine the voltage drop across the resistor R1. No. Resistor R1, yeah, it's given as 18 ohms, okay? Determine the voltage drop, which means if you know the current, you multiply it with resistance, you get the voltage drop across that resistance. Therefore, you need to calculate the current through the entire circuit. Calculate the voltage drop across resistance R1 in the circuit, that's all. So, what is this? This and this is in series, 15. That and this 10 is in parallel. So, 10 into 15 by 10 plus 15. What is it? It's 150 by 25. 25 6 are 150. So, then till here it becomes 6. That 6 and this 8 is in series. 18 plus 6 makes it 24 ohms. You know the current will be 60 by voltage by resistance, 60 by 24. Whatever that is, can we cancel with 12 2s are 24, 12 5s are 60. Therefore, the answer is 2.5 amps. If you know the current through this circuit is 2.5 amps, you can multiply that with 18, that will give you the potential drop across the 18 volts. So, 18 into 2.5, okay, 18 into 2.5, 18 into 2 is 36, 18 into 0.5 is 9, so 45 will be the potential drop. What? Answer is 15 volts. Why I am not doing well? What is the problem? So, can you just multiply 18 into 2.5? 18 into 25, 5 5s are 43, 5 1s are 5, 9, 8 2s are 16, 2 1s are 2, 3, 0, 15, 45. Yeah, I am getting that only. So, the answer is tending to be wrong. Let's find out what is the mistake. So, the answer is actually correct. You get a 45 volts. I think that you have to change this potential drop across this as 45. This is, I think it's 45. I have written it's 15. No, change it. It has to be 45 volts, guys. It has got to be 45 volts. Okay, change this PDF. Okay, so let's go to next. Make sure you do the corrections in the PDF. Okay, let's go to next question. See, if they ask you what is the current through this 10 ohms, what will you do?
We have to multiply it with.
The current that's coming here will go like this and go like this. The current 2.5. You know this is 10 and this is 15. If the resistance is in the ratio 10 is to 15, the current will be in the ratio 15 is to 10. Do you understand what I am saying? Those are the very, very basic things I will teach you with. Supposing in the question they ask you the current flowing through the 10 ohm resistor and this series, this circuit. You know the resistance is in the ratio for this wing, let me write in red color, this and this is 10 is to 15, which itself is 2 is to 3. The resistance is in the ratio 2 is to 3, the current will be in the ratio 3 is to 2, which is 3 by 5 of the total current 2.5, and for this wing it is 3 by 5 of 2 by 5 of 3.5. So, you can calculate the respective currents in the first one and in the second one and multiply it with this 10 ohms, you get the potential across this and this. Thus, you can find the potential across this and this, correct? Or you can also do one thing, it is very simple. You know this whole thing is parallel. So, this potential across this and this will be the same as this and this. The potential across this and this will be the potential across this and this end, because there is no resistor there, will be the same as this and this. And you know this 60 volts you found this potential to be 40, the balance 20 will be coming here. It will be 20 volts here also and 20 volts here also. So, you know the potential, you know the resistance, you can find the current through the respective resistance. Very, very easy way of finding. Okay, if you can remember it, well and good. So, let's go to next question. Next question is the 14th question. You have a circuit which is like this. I hope I can find the circuit here. It's like this. So, you have a 7 ohms here, you have a 3 ohms here, 10 ohms here, and you have a 5 ohms here, and this will be a cross which will be
10.
a 10 ohm. So what are we going to do? Find the equivalent resistance RAB. What is the meaning of, what is ABCD? This is A, this is B, this is C, and this is D. When they say equivalent resistance across RAB means you should extend the wire like this immediately. They are asking across RAB means this becomes parallel to the entire unit. You have to extend the wire. You know these two are in series now. 7 plus 3, 10. That 10 and this 10 is in parallel, which will be 10 into 10 by 10 plus 10, which is just 5. 5. That 5 and this 5 are now in series. So this 10. That 10 and this 10 are is in parallel. Correct? So 10 into 10 by 10 plus 10, again it's 5. So 5 ohms should be the answer, we got it. Okay, next step. What is the question? They are asking between A and D. Immediately you should change the circuit. Between A and D means you should extend the wire like this. Yeah, then in that case these two will become series. 15. That 15 and 10 will become parallel. 10 into 15 by 10 plus 15. That answer the 7 ohms becomes series. That and the 3 ohms becomes parallel, and thus you get it. So you get the different values. Are you clear? I am not doing anything more. So you can have understood. Let's go to next question. It's the 15th question. Whenever they say AB means you should extend the wire and treat that part to be in parallel to the entire circuit. Let's go to 15th question. So the 15th question, you have a resistance like this, 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 resistance. This is A, this is B, this is F. Okay, whatever this is 3 ohms and this is 3 ohms. These two are in, see the potential across AB is what they are asking. So immediately you will extend this wire. This should be treated in parallel to the entire circuit. So you know these 3 and this 3 are in series. That 6 3 plus 6 and 6 are in parallel, it will become 3. 6 and 6 parallel means 6 into 6 by 6 plus 6 is just half of it. Okay, which is the 6. This 6, this is just 3. That 3 and this 3 now is in series 6. That 6 and this 6 will be 3. 3 plus 3, 6. 6 and 6, 3. 3 and 3, 6. So you get a 6 and that 6 will be in parallel to this 3, which is 6 into 3 by 6 plus 3. 6 into 3 is 18, 6 plus 3 is 9. So the equivalent resistance is 2 ohms. What? 6, where is it? Above written what? 2 ohms. Correct. Okay. So are you clear? So let's go to next question, which is the 16th question. Find the effective resistance of the network. See, look at this network here. You have a wire like this, a 6 ohm resistor. What is this? A 12 ohm resistor. This is a 12 ohm resistor, a 6 ohm resistor, a switch like this and like this, a 12 ohm resistor and a 6 ohm resistor, and this is A and this is B. Are you coming? So this is the circuit. Okay. If the switch is closed, it's different. Switch is open means it's different. Come here. If the switch is open, there is no current which is flow through here. So this two will become series, this two will become series, and those two will become parallel. Very simple. This is 18 and this is 18. 18 into 18 by 18 and 18 parallel is 9 ohms. 9 ohms. But if the switch is closed, let's think of a situation where the switch is closed. This moment the switch is closed, the current will start flowing in like this. So this and this itself is parallel. This and this itself is parallel, and those two will be in series. Are you clear? So it's 6 into 12 by 6 plus 12. This is also 12 into 6 by 12 plus 6. But they both are in parallel, the answer of it by half. They both are in series, sorry. These two parallel, then those two has to be in series. So just add it up. So can I go, you should get the answer. Can I go to next question? Are you clear with that? It's very, very important. So let's go to next question, which is the 17th question. So 17th question, you see this circuit is like this, a 5 ohms, a 10 ohms, again a 10 ohms, then 5 ohms, then a 10 ohms and a 10 ohms, correct? Can you see? Normally there will be a hook like this, there will be a hook here. There outside there is a 10 volts, okay? Outside there is a 10 volts and you can see it from the diagram, okay? Normally there will be a hook like this, the wire which goes here, no? Will go like this and like this, which means these two are in series. Where there is hook, those two are in series, but there is no hook. In this diagram, there is no hook, it's a straight wire. What is given is a straight wire, there is no hook here, which means this and this is in parallel, this is in parallel, and those two are in series. Are you clear? So 10 and 10 is in parallel, 5. 10 and 10 is in parallel, which is 5. 5 and 5 on series, which makes is 10. That 10 and this 5 are in parallel. So 1 by 5 plus 1 by 10 plus 1 by 5 will be like this, and you can get the equivalent resistance. You know the voltage is 10 volts, with which you can calculate the current. I is equal to V by equivalent resistance R, and then you get the answer as 5 amps, and that's about it. You do it, you will get it. You understand there is hook, this and this will be in series, and this and this will be in series, and those two will eventually be in parallel. But there is no hook here, which means this and this is in parallel, this and this in parallel, eventually they become in series. Are you clear? Now let's go to next question. So next question is the 18th question. It's the world's most important question. You have a 6-volt battery. Okay, one second, hold on. This is some of the world's most important sum. You have a battery which is a 6-volt battery. அதுக்கப்புறம் இந்த இடத்துல ஒரு resistor which is 15 ohms. அப்புறம் இந்த இடத்துல ஒரு 10 ohms. அப்புறம் இங்கே ஒரு battery which is 2 volt. 2 volt. அப்புறம் இங்கே ஒரு resistor capital இது unknown resistor, இதான் நீ கண்டுபிடிக்க வேண்டியது. அப்புறம் இங்கேருந்து ஒரு 30 ohm resistor, அண்ட் இங்கேருந்து ஒரு 5 ohm resistor, அண்ட் இப்படி வந்துட்டு இங்கே ஒரு ஐ திங்க் 5 ohm தான் அது நினைக்கிறேன், இப்படி கனெக்ட் ஆகிருக்கு. ஏபின்னு ஒரு பாயிண்ட் கொடுத்துருக்காங்க, இந்த இடத்துல சீன் ஏதோ மார்க் பண்ணியிருக்கேன். அண்ட் என்ன கொடுத்துருக்காங்க, calculate the value of the resistance R so that the current in the circuit is 0. current circuit level கொடுத்துட்டாங்க 0.2 amps. What will be the potential difference between A and B? The question. Okay, current through the circuit is 0.2 amps கொடுத்தா எங்கே இருக்குது அந்த கரண்ட்னா இங்கே தான் பேட்டரி இருக்குது. ஸோ இங்கே தான் நான் கரண்ட் போடணும். ஸோ நார்மலி நான் கரண்ட் வந்து நான் ஃப்ரம் த பாசிட்டிவ் தான் இப்படி தான் போடுவேன். பட் இந்த சம்மில் நான் இப்படி போட்டிருக்கேன். டசன்ட் மேட்ரு, இப்படி போட்டாலும் டசன்ட் மேட்ரு. ஓகே, ஸோ தென் திஸ் இப்படி போட்டிருக்கேன். அது கொடுத்துருப்பானா இருக்கும். தே மஸ்ட் ஹவ் கிவன் இன் த கொஷின் தட் திஸ் இஸ் த டைரக்ஷன் ஆஃப் கரண்ட் அண்ட் 0.2 ஆம்ஸ்ட்டு கொடுத்துருப்பான். அவனே கொடுத்துருந்தா பிரச்சனை இல்லை. ஸோ அப்படி கொடுத்துருக்கானும் போது இப்போ இந்த ரெசிஸ்டன்ஸ் நீ கண்டுபிடிக்கணும். ஓகே, ரொம்ப ரொம்ப ஈஸி. கிர்ச்சாஃப் லூப் ரூல் வச்சு ஃபஸ்ட் வந்து பொட்டன்ஷியல் டிஃப்ரென்ஸ் பிட்வீன் ஏ அண்ட் பி கண்டுபிடிக்கணும். ஏ அண்ட் பி ஓகே கண்டுபிடிக்கணும். அப்புறமா the potential difference between A and B is the same as இப்படி வந்தால் கூட the potential difference between this and this, because இங்கே ரெசிஸ்டரே இல்லை, இந்த இடத்துல ரெசிஸ்டர் இல்லாதனால இந்த பொட்டன்ஷியல், அப்புறம் இப்படி வந்தாலும் இந்த பொட்டன்ஷியல் எல்லாமே சேமாக இருக்கும். அதாவது இந்த விங்குக்கு மூணுத்துக்கும் சேம் பொட்டன்ஷியல் தான் அப்படிங்கிறது உனக்கு ஃபஸ்ட்டு தெரிஞ்சிடும். ஸோ ஏபி கண்டுபிடிக்கணும், எதை கண்டுபிடிச்சாலும் போதும். ஓகே, ஸோ now coming back, let's do a loop rule. Let's do a loop rule only for this. What is the question say? Calculate the value of the resistance. So the current in the circuit is 0.2 ohms. What would be the potential difference between A and B? So let's consider loop rule like this. பண்ணலாமா? loop rule பண்ணால் இந்த இடத்துல இங்கேருந்து போகலாம், நெகட்டிவ் டு பாசிட்டிவ். ஸோ +2 இப்படி வந்தீங்கன்னா current is going in the opposite direction, plus 0.2 into R. இப்படி போனீங்கன்னா current is going இந்த இடத்துல current என்னன்னு உனக்கு தெரியாது. You don't know what is the current in here, correctா? இங்கே மாத்திரம்தான் 0.2, இங்கே மாத்திரம்தான் 0.2. இங்கே வந்து it's going to get split. Yes or no? Correct? How will it get split? This is 15 ohms, this is 30 ohms, and this is 10 ohms. Okay, so then என்ன பண்ணலாம்? Okay, we have to consider some current here. We don't have a choice, correct? We have to consider some current I1. The current flows here as I1 and will flow here as I2 and I3 or whatever it is, correct? Yeah, so let's consider this. Then I'm going in this direction. So opposite current opposite varudha, which is plus I1 into 15. Then go like this, minus 6. Then go like this. The current is flowing in the opposite direction, plus 2 is equal to 0. Correct? So I don't know R also, I don't know I1 also in this circuit, correct? So what is the answer I'm getting? Minus 6 plus 2 is minus 4. Minus 4 plus 2 is minus 2.
Here isn't it 10?
What is 10 ohms? Are you okay? Okay, let me undo it from the beginning. Guys, just hold on, I'll undo it from the beginning. That's a 10 ohms. My own handwriting I can't understand most of the time. Okay, so this is 10 ohms. Okay, and this is 2 volts. I'm going to go in one direction. See here, I know the current here is 0.2, so the current here is also 0.2. That doesn't mean the current here is 0.2. It can be a different current. It can be a different current here. It can be a different current here. Can we calculate this to be? Can you see this is 5 and 5, which is 10. So this is 10 and 30 and 15 are together, put together they are in parallel. So 1 by 10 plus 1 by 30 plus 1 by 15. LCM is 30, 10 3s are 30, 3 plus 1 plus 15 2s are 30, so which is itself 6 by 30, which is 1 by 5. Therefore this whole thing is just 5. It's just 5. Can I do one thing? Can I redraw the diagram? So this is 10 ohms, this is a 2 volt, and there is a resistance, unknown resistance R, and there is a battery here 6 volts, and this is to put together this is what? This put together is 5 ohms, equivalent to 5 ohms. Now can I just simply do a loop rule here? Simply do a loop rule here. The current flowing through here will be the same as the current flowing through here also, no problem. So then consider loop rule. Let's go from here. Negative to positive, it's plus 2. Current is going in the opposite direction, so 0.2 into R. 0.2 into R. And the same current is flowing in the opposite direction. Plus 0.2 into 5. Plus the voltage is going from positive to negative, minus 6. It's 10 ohms, the current is coming in opposite direction. 0.2 into 10 is equal to 0. Let's calculate this as 2 plus 0.2 R plus this is 1 minus 6 plus 2. What is this? 2 and 2 becomes 4, minus 6 means it becomes minus 2. Minus 2 plus 1 becomes minus 2 plus 1 becomes minus 1. 0.2 R minus 1 is equal to 0. So R is equal to 1 by 0.2 or a 10 by 2. So can you say that the unknown resistor is 5 ohms? The unknown resistor itself is 5 ohms. Yeah, we got it. Is it so easy to do it like this? It's so easy. Instead of thinking of anything else, just consider the resistance and redraw the circuit, and then you know this is the same current which will flow through this effective 5 ohms, and it becomes easy. So let's go to next question. The potential difference across the capacitor. Okay, this is some number. You have a 3 ohm resistor, you have another 3 ohm resistor, you have a 3 ohm resistor, you have a capacitor. Are you listening? A 3 ohm resistor, you're distracted. A 3 ohm resistor, and you have a battery like this. They are given this as 15 volts. They are asking us to find the potential difference across the capacitor. What is the meaning of it? Potential difference across the capacitor means just across this. Only that part. Which means you need to, let's name it as A and B, or whatever I named it as. I named it as this is A. This is A, B, C, D and E and F. It's basically C and E. How are we going to do that? Okay. See, do you know that the potential across this and this in this way will be the same as this and this? Therefore, we can ignore this circuit for now, because the potential is anyway the same. So let's redraw the circuit without it. Okay. So then let's redraw the circuit without it. Yeah. Just take it off. So then this point is here, C and F. If you find the potential across CF, you can find the potential same as the potential across that direction CF. Correct? Up direction CF. So then this is 3 ohms, this is 3 ohms, and this is 3 ohms, 3 ohms and a 3 ohms. If you reconstruct like this, otherwise you can't do the sum. Then these two are in series, 6. That 6 and this 3 is in parallel, which is 6 into 3 by 6 plus 3, which is 18 by 9, which is 2 ohms, and that 2 and this 3 is in series. So 2 and 3 becomes 5 ohms. To find the current, I is equal to V by R. So which is 15 by 5, which is 3 amps is the current. You know 3 amps is the current that is flowing through here. It will get split variously across this, but when it comes here it will still be 3 amps. But this 3 amps and this 3 ohms, when you multiply IR, you get the potential across this point and this point, which itself is 6 volts. So you know the potential across this is 6 volts, the total is 15 volts. So 15 minus 6 will leave you behind with this as 9 volts. Therefore, you know the potential difference across this and this itself is 9 volts whenever they come like this or come like that. Correct? And you know this is 9 volts and a 3 ohms, you can divide and get the value of current. You know I is equal to V by R, therefore the 9 by 3 is 3 amps is the current that is flowing through here. So you know the current through the outer circuit itself is 3 amps. Huh? What? What is the current through the outer circuit? What is the equivalent resistance that we got here? We ignored the circuit, we redrew. And we said that 3 and 3, 3 amps and 3 amps. Yeah, you got a 3 and 3 makes it series. 3 and 3 makes it series, which is 6 and 3 makes it parallel. So you get up 6 into 3 by 6 plus 3, which is 18 by 9, which is 2 amps, and the 2 and this 3 becomes 5. Yeah, so equivalent resistance became 5, and I is equal to 3 amps. Yeah, you got a 3 amps here, right? And that 3 amps you put here, and you got a voltage as
6.
Because V is equal to IR. You got 15 minus 6 is 9. So you got this voltage to be 9. You know the resistance here is 3, and what is the current? I is equal to V by R, 9 by 3. I am getting 3 amps. It can't be 3 amps there. Is it 3 ohms? This is not 6, it's 3 3s are 9 volt. I into R, 3 into 3 has to be 9. So therefore this side will be only 6 volt. So you know voltage, you know the resistance 6 by 3 is 2 amps. So therefore here 1 amp will flow. So 1 amp flows through here. These are series. So then 1 into 3 is 3 volts, and 1 into 3 is 3 volts. 3 plus 3, 6 volts is the potential difference between this and this is again. Obviously they parallel, so it will be 6 volts only. So you know that, see in this there is this extra circuit is there on the top. If you know the potential between this and this, the potential difference between this and this, you know this itself is 3 volts, this itself is 3 volts, therefore you know this is 3 volts. You know this itself is 6 volts, 9, what did you call, 9 volts. 9 plus 3, 12 volts. So therefore the potential difference between this end and this end itself is 12 volts, correct? Yeah, 12 volts. Now we have to find the current through in here. Yeah, this itself is 12 volts. Okay, now you know this voltage, this is 12 volts from here to here, and that will be the same on the top circuit. You know this is given as 3 microfarad. You know the capacitance of the capacitor, and you know this capacitance of this capacitor is 3 microfarad, and this resistance is 3 ohms. Okay, look at this, it's a little detail here. This is a 3 ohm. Similarly, this is also a 3 ohm. This network and this network are similar networks. If the voltage across this is 3 volts, we can say the voltage across this 3 ohms will also be 3 volts, and therefore 12 minus 3, this will become 9 volts, and 9 volts will be the potential across the capacitor, and we can leave it like that. It's such a complex sum, it's not a very easy sum. First thing is you should identify to get the potential between the capacitor which comes in this circuit. You basically should consider, take this off separately from here to here, because that potential and this potential are just the same. Take this circuit off, redraw it without it, mark the currents, then find the potential difference to be this plus this potential, which is 12 volts. But this is made of 3 ohms and 9 ohms. This is made of 3 ohms and a capacitor. So the 3 volts and 3 volts will be the same anyway. So then therefore this is 3 volts. 3 ohms and 3 ohms will have the same voltage. The rest of it will go to the capacitor. So 9 volt will be the potential across the capacitor. Are you clear? So can I go to the next question? Here it is. 20. A battery of EM of 10 volts is connected to a resistance shown. Find the potential difference across A and B. You know, the first, you just redraw the circuit. This is the circuit, correct? The circuit, you know, these two are series, 1 ohm and 3 ohm, and a 3 ohm and a 1 ohm makes it 4 and 4, which is 2 ohms, totally in parallel. You know, the voltage is 10, so 10 by 5 is equal to, 10 by 2 is equal to 5 amps is the current that is flowing through here, correct? This is getting equally split resistance, 1:1 ratio. The current will go as 5 amps, 2.5 here and a 2.5 here. And if you multiply the 2.5 into this resistance, you get the voltage across this and this. You multiply the 2.5 into 3, you get the voltage across this and this. Let's name this as A, and this is B, and this is C. You know the 2.5 into 1, which is 2.5 volts, is the voltage across CB, VCB. Then voltage VCA, VCB will be 2.5 into 3, which is 7.5. The potential difference between this will be, subtract this, you will get 5 volts to be the potential, that's all. Potential difference between A and B. Are you clear? So let's go to next question. The world's most important question. When you have something like this, a circuit like this, with a wire going like this and a wire going like this, which means there is no resistor here. If there is a resistor, it is like a Wheatstone's bridge. If there is a resistor on the top and the bottom, this is equal to a Wheatstone's bridge. But there is no resistor, which means, look at this, the wire goes from here, it comes like this, comes like this. There's no resistor. Okay. No resistor here. So then this wire comes like this, goes here and here. So one end is connected to 3 resistors. One end itself is connected to 3 different resistors. Let's take the other end. It goes here and here. So this end is connected to 3 different resistors. So therefore it becomes parallel. This is nothing but this circuit. Are you clear? That's all. And then it's a question of, this is 2R, 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 1 by 2R plus 1 by 2R plus 1 by 2R, you get the answer, reciprocal it, okay. So let's go to next question. This is the 22nd sum. You have a battery like this, you have a resistor, you have another resistor like this, you have a resistor like this, you have a circuit, you have a resistor like this. This is R3, this is R4, this is R2. What is given here? What have I written there? 5 amps. Where is the sum here? We finished all these sums here. R1, I1, a current of I1 and resistance R1. This is R2, this is R4, this is R3. What are the currents that's given is I1, this is I2, this is I3 and this is I4 has been given in the question, okay. And they have given the values of all the resistors R1, R2, R3, R4 is 4 ohms, all that has been given, okay. Have I written it here? I have not written it, the question, yeah, it's here, R1, R2, everything is given. So you know that, let's calculate the, what is the current, what is the equivalent resistance, okay. Well, how about this, okay, see here, this and this are all in parallel. The R2, R4 and R5, all the 3 are in parallel. 1 by R2 plus 1 by R4 plus 1 by R3. Just fill in all the values and you will get 6 ohms to be the resistor, equivalent resistance. Reciprocally to get 6 ohms. So that with this R1 will be in series. R1's value itself is given to be 4 ohms. So 6 plus 4 is a 10 ohms is the equivalent resistance in the circuit. The voltage of the circuit, the EMF of the circuit is given to be 10 volts. And 10 ohms is the equivalent resistance. So the current through the circuit will be 1 amp. Thus you get the current through the circuit to be 1 amp. Then you multiply that ampere into this resistance. This resistance was R1 which is 4. So 4 volt goes here. So balance, this is a 10 volt. 10 minus 4 will be 6 volt will be the voltage which will appear across this, correct? So I hope you understood. Since this potential is 10 volts, you multiply the current with this resistance which is given to be 4, you get a 4 volt. 10 minus 4, 6 volt, the potential difference between this is 6 volts, the potential this and this is 6 volts, potential this and this is, everything is 6 volts. You know the value of voltage, you know the value of the resistance, you can divide V by R and you get the respective currents, that's all. You can find the individual currents. It's so easy, right? Whatever you want you can find. Let's go to next question. So do it and find every current and see if you're getting the answer. Look at this sum. You have some, is there a hook here? No, there's no hook. And can you see this sum is like this, like this, like this, like this and like this, it's similar to Kirchhoff's loop rule. Correct? Kirchhoff Wheatstone's bridge. So what is it? Wheatstone's bridge. Again like this, like this, like this, like this, resembles Wheatstone's bridge. And you have like this and connected like this. This is R, P by Q is equal to R by S, so no current will flow through the middle wire. And then this is R and so no current will flow through the middle wire again. These two are in series, these two are in series. So it will be 2R and 2R and they are both on parallel, so R. These two are in series, these two are in series, which is 2R and 2R and they both are in parallel, so R. That R and this R will be in parallel. So 1 by R plus R into R by R into R by R plus R is R square by 2R. So R by 2. This is 0.5 into R, correct. R by 2 0.5 into R. Let's go to next sum. The next sum, can you see here that you have like this and a kutti resistor like this. They both are in parallel. You have a resistor like this, another resistor like this. They both are in parallel. You have a resistor like this, another resistor like this. They both are in parallel. You have extended like this. So you know these two are in parallel. R and R will get you R by 2. These two are in parallel. R and R will get you R by 2. These two are parallel. R by R will get you R by 2. But these two are in series. So it will become R. That R and this R by 2 will be in parallel. That's all. Are you clear? Can I go to next sum? So look at this. This is A. From here there's a resistor like this, there's a resistor like this, there's a resistor like this, and it goes like this. There's R and one more resistor here R, correct? And this is the point B. They are asking potential equivalent distance between A and B. You must see here how I am doing. Come here. The wire goes like this, it gets split up like this into 3. Can I say that these 3 are in parallel and that is in series with this R? The current is going to get split like this, split like this. Can you see that? Can I consider these 3 are in parallel? 1 by R plus 1 by R plus 1 by R, which is 3 by R, so R by 3. And that is in series with this R by 3 plus R, which is 4R by 3. Would it be the answer? Yeah, that's the answer. You understand how I am looking at it? So let's look at the next drawing. Can you see the next drawing? It's like this, and you have a B, and you have the center point, which is the A, from which there is a resistor like this, a resistor like completed. Every resistor like this. Okay, what can you say that between A and B? From A you start. Okay, from A you start, and go like this. There's a resistor here. There's a resistor here, and there's a resistor here. Can I consider all the 3 to be in parallel? These 3 to be in parallel, and that is in series with this R. The same way.
And then it's connected.
So which means all the 4 are in parallel. So 1 by R plus 1 by R plus 1 by R plus, since it's also connected to this end, 1 by it's 4 by R, so R by 4. Is it correct? Yeah. So let's go to next question. We have a circle like this, wherein you have a resistor, resistor, a resistor, a resistor, and a resistor, and a resistor. Correct? This R, this R. What can you say? This is about between A and B. You know that this is Kirchhoff law. R and R. P by Q is equal to R by S, so no current will flow through here. Therefore, these two are in series, which is 2R. These two are in series, which is 2R. Those two are in parallel. 1 by 2R. It's just 2R, 2R. So R, half of it. So R should be cancelled. So let's go to next question. Can you see a hook here in this question? If you see a hook, it's very simple. We'll do the sum like that. This 2 and this 2, the hook around side of hook. Series, these 2 are in series, those 2 are in parallel. And that and the top and the bottom will also be in parallel. That's all. Done? Can I go to next question? Where is this? Okay, can you see this? This I already taught you, right? This is simply parallel. R parallel, but this is loop rule. This is Kirchhoff law. When you have something on the top, it's like you have to draw it like this, like this, like this, like this, and like this. This and this circuit are same. Can you see the top R? The top R is here. This R is here. This R is here. This R is here. The middle R is here. So therefore, this becomes a loop rule, and if this and this are proportional, no current will flow through here. These two series, those two are in parallel. That's all. Okay. So can I go to next sum? Look at this. This 4 and 2 are in series. 6 and 3 is in parallel. That and this 4 is in series. That and this is in parallel. Yeah, and that and this is in series, and so on. So you have to find it. You can do it yourself. Correct? Can I go to next sum? And this and all I taught you all the graphs yesterday. I have taught you very, very important graphs. Correct? And this sum is a very, very important sum. A very weird sum. You have a 10 ohm, 10 ohm, and 10 ohm. This point is A and this point is B. And you have a 10 ohm, a 10 ohm, and a 10 ohm. The point is D and a C. And this itself is 10 ohm, and this itself is a 10 ohm. And can you see, if they are asking me to find the resistance between A and B, equivalent resistance between A and B. A and B, which means I can take this circuit off. By symmetry, you can remove it. You can just remove it. Then these three will be in series. which will make it 30. That and this 10 ohm will be in parallel, and that and all the other two will be in series. That's how you should find the equivalent resistance, find the answer. Are you clear? Between D and C means you will ignore if they ask you between D and C, you will ignore this part and this part. You will come same. Next is, supposing they ask you between A and C, what do we do? Okay, between A and C means A is here, C is here. So, you will want this circuit, this circuit, this circuit and this circuit, this circuit, this circuit and this circuit. You will delete this and this. You will take this portion off and this portion off. Then in that case, these two will be in series, these two will be in series, those two will be in parallel, which will be in series with all the three. Are you clear? That's what makes this sum. And next is, look at this question. In the circuit, the cells even, okay. This sum is the world's most important sum, marked important. So you have hey, யாருதா ஆலையா? உனக்கு பார்க்க தெரியாதா?
Now it's recording.
Now it's recording, sure.
Now it's recording.
Okay. So then இதெல்லாம் அதில் வந்திருக்கும் ரெக்கார்டிங்கில். ஓகே, இது வந்து 4 வோல்ட், ஓகேவா? இது வந்து 8 வோல்ட்ஸ், இது 4 வோல்ட்ஸ், இது 8 வோல்ட்ஸ். இது பாசிட்டிவ் கனெக்டாக இருக்குது. இப்படி இருந்தாலே ஒன் பேட்டரி இஸ் கெட்டிங் சார்ஜ் பை தி அதர் பேட்டரின்னு அர்த்தம். ஓகே, ஸோ இங்கே ஒரு 4.5 ஓம்ஸ், இங்கே ஒரு இங்கே இப்படி வந்துட்டு இங்கே ஒரு 6 ஓம்ஸ், இங்கே ஒரு 3 ஓம்ஸ், அண்ட் இங்கே வந்து இப்படி இது 3 ஓம்ஸ், இது 6 ஓம்ஸ், இது 4.5 ஓம்ஸ், இப்படி ஒரு சர்க்யூட் இருக்குது. இது வந்து இது ரெண்டும் பேரலல். 6 and 3 is in parallel. 6 into 3 by 6 into 3 by 6 plus 3 is 18 by 9, 2. Correct? 2 and this is 4.5, so equivalent is 6.5. ஆனால் இதில் internal resistance வேறு கொடுத்துருக்காங்க. This is 0.5. This is 1 ohm. So இதையும் சேர்த்து ஆட் பண்ணோம். 6.5 plus 0.5, 1.5. Totally the equivalent resistance therefore is 8 ohms. What is the voltage? Voltage is 8 minus 4. Because positive and positive, negative, so it's 4 by 8 is V by R, equivalent resistance. So it's 1 by 2. Therefore a 0.5 amps current is what is flowing through the circuit. Correct? I is equal to 0.5. So the primary circuit la dhaan mark pannom. நானே mark பண்ணிருக்கேன், ஏதோ ஒரு directionல current mark பண்ணிருக்கேன். இந்த current இது வந்து 0.5 amps அப்படின்னு mark பண்ணிருக்கேன். இப்போ இந்த 0.5 amps வந்து இப்படி flow ஆகுதுல, இது 6 and this is 3, which is in the ratio 1:2. Resistance is in the ratio 1:2. Current will be in the ratio 2:1. So 2 by 3 of 1.5. 1.5 or 0.5? 0.5. And 2 by 3 of 0.5. That will be the current that is going to flow through the up and through the down. 2 by 3 of 0.5 is 1 by 3. 5 2s are 10. And 2 by 3 of then see it's 1 by 3. 2 by 3 and 1 by 3. 1 by 3 is 0.5 by 3. Correct? 1 by 3 and this is 0.5 by 3. அப்படின்னு இந்த ரெஸ்பெக்டிவ் கரண்ட்ஸ் கிடச்சிருது. இந்த கரண்ட் ரெஸ்பெக்டிவ் கரண்ட்ஸ் எனக்கு கிடச்சிருது. அதுக்கப்புறமா ஐயோ where is the sum? I get 1 by 3 and 1 by 6 to be the respective currents. That's all they are asking. Okay, you got the current through that's all they are asking. But having said that, the question may get extended. They will ask you one most important question in this. They will ask you to find this is EMF. They will ask you to find the terminal potential difference V. You know V is equal to E minus IR. They will ask you, E, a current now, which is 0.5. You know the internal resistance. Therefore, you can find the potential across this and this. But you should know that this sum pertains to charging, where the 4 volt battery is getting charged by the 6 volts. When it is getting charged, it's E plus IR because current direction will be opposite.
Okay.
So V is equal to E plus IR for this one, and V is equal to E minus IR for this one. Will give you the respective voltages, and that is the question which will come. That question is not given here. The question will definitely be about terminal potential difference only, and this is the way you should calculate. I hope you are clear. So we'll continue in the next video the rest of the sums. For now, I would have covered at least 25% of the required numerical and 100% of the theory. So